Hallo, it's dumplet here. Here's an item on trigonometry. Evaluate the inverse tangent of 1/2 plus the inverse tangent of 1/3. As usual, pause this video if you'd like to give this item a try. But if you're done, let us dive into the solution. Now, a little spoiler over here, and that this evaluates to a very nice angle, and we'll be able to see what this angle is in a while. But well, just a little bit of note, since we have inverse tangents here, well, we expect that the result is going to be an angle. So because tangent theta, we take the inverse tangent, so we're going to get theta back. So since this is an angle, why not make this equal to theta for now? And since we have a lot of tangents, inverse tangents, we can use the tangent function. So let's just try to take the tangent of this angle theta. Now we can use the following identity. Tangent of the inverse tangent of x equals x. That's just because the function, so f of the inverse of f of x, f of its inverse is just whatever you put inside. So just the property of inverse functions. So the tangent of the inverse tangent of 1/2, that becomes 1/2. The tangent of the inverse tangent of 1/3 becomes 1/3. So this part, it just came from the tangent addition formula, tangent A plus tangent B, all over 1 minus tangent A tangent B. So that's just from our identities from the tangent addition formula. So since we let the substitution be this angle would be theta, so we have tangent of theta, this is the thing that we want, is equal to 1/2 plus 1/3 over 1 minus 1/2 times 1/3. You can simplify this a little bit. The numerator becomes 5 over 6, and then the denominator becomes 1 minus 1 over 6, and 1 minus 1 over 6 is just 5/6 as well. So it's actually very nice. Tangent theta over here is equal to 1. Now, tangent theta equals 1 is actually nice because we actually have like a list of values for theta that we know. Like for example, theta can be, by the way, we're just going to express everything in radians just because it's not given, like if it's in degrees or radians. But just to standardize everything, let's just use in radians. So we have possible values for theta like pi over 4. Another would be 5 pi over 4. And then 9 pi over 4. So, pi over 4 plus a multiple of pi. So there's a lot of values of theta, but obviously there's only one possible answer, and that's because of the inverse tangent function that we have. Now, the inverse tangent, it outputs, or the range of an inverse tangent is from negative pi over 2 to pi over 2, but we can restrict it to 0 to pi over 2 simply because we know we can try to take the tangent of this blue part here. So the tangent of the blue part is 1/2. So this angle should be in the first quadrant since it's positive. So since 1/2 is positive, and same for the 1/3 over here. So that's why you see that I labeled this as, we don't know the exact value, but we know it's between 0 and pi over 2, and same for the green one. So since 1/2 and 1/3, they're both positive, so both of these angles, the blue and the green angle, must be in the first quadrant. So since both of those angles are in the first quadrant, we take the sum, then we can conclude that this sum lies in the range 0 to pi. Now, combining with the fact that I've listed some values over here, pi over 4, 5 pi over 4, 9 pi over 4, and so on. Well, indeed, there's a lot of values of theta that might work, but the only one that lies within the range is, in fact, only pi over 4. And pi over 4 in degrees is just 45, so it's the tangent 45 equals 1 that we know. And in fact, pi over 4 is our only answer because only pi over 4 lies in the range of theta that we got. And this will be our final answer. Hopefully you guys learned something new from this video, and I'll see you in the next one. Bye bye!